This is a problem balancing of rotating masses at different plane, and in this problem I can see that it is given that the four masses A, B, C, D are completely balanced. They are given that it is completely balanced. They are not asking us to balance. They are saying that it is completely balanced and they are asking to find out the unknowns. So now we are going to represent the A, B, C, D. Here they are given the distance between the B and C alone. So let us draw the mass. So distance between B and C is given in the question. So distance between B and C is given as 300. That is what given in the question. And the other distance, that is the distance between this and this, from B to this is unknown. So we take it as Y, and this B to D is also unknown, take it as X. Only the distance between B and C is given in the question. Now we take this as a reference point. Reference. So this side it will be negative and this side it will be positive. So that is what we have finished drawing this diagram. We are going to draw the next view of this diagram. It's what given in the question. We know it is the angle between B and C is 90 degrees. That is working. B and C is 90 degrees. So we will start with the B and C. So this is B and C is 90 degrees. So we take this. So somewhere here. So we put it in. So this is C. So now it is also given that the angle between B and D is 210 and C and D is 120. So I take this 120. Let me draw this. So this is a D point. So the unknown is B, C, D we have put. The A is going to be here, and the mass A radius they are given. The mass is not given. That is what we have to find out. So we mark it here. This is 90 degree, and the distance is 120 degree, and this is 30 kg. This is 50 kg. This is 40 kg, and the distance is 240, 120 and 150. So now we can start filling this table. So we'll start filling the table for it. So we put plane the mass, radius and centrifugal force. As usual, m into r, and the distance L, and couple m r into L. So we can fill the values as usual for A, B, C and D. A, and we have taken the corresponding values for A, B, C, D. So mass, we don't know the mass of A, so we take it as MA. Other masses are there, we are writing it. The radius, we are converting into meters and writing it over here. Multiplying this and getting the centrifugal forces. The length from the reference for each masses from here to here is y, so it is a negative direction, so minus y. This is a reference point, so 0. From here to here 300 millimeters, so 0.3. From here to here it is x. So when we multiply this and get this, you can see here in centrifugal force and coupled force, unlike the other problem, the coupled force we have got 2 unknown, whereas in centrifugal force we have got only 1 unknown. So we should not draw that coupled force first. We have to draw the centrifugal force polygon first to get this unknown, so that we can solve for the other one. So we are going to start doing it. So now we are drawing this one first. Vector corresponding to this B. So for B, this is the thing that we are going to see. This is the values that we are going to refer for the force polygon. So I am just highlighting it. So 7.2, that is corresponding to this vector. So 7.2 I am drawing. So next is corresponding to C is a D. Corresponding to C is D. So when you draw this parallel to this is 90 degree only, so it is easy. This is 90 degree, so just you can put like this. So I did not take it, but I am showing it for you like this. Put it. So the length of it is 6. So I take it as 6. Length is 6. Length is 6. So I got this is 7.2 and this is 6. And the other vector is in this direction, D. For D, the force is 6 kg meter. So 6. So I am going to draw the parallel line for this. So I am going to keep it like this and draw the parallel line. So I am keeping it parallel and then locking that, keeping it parallel and then locking it. Now I move it to get the line. So I will draw the reference line first. It is 6, so let me draw 6 for it. It is 6. So when you mark it is O, D, C. O, B, C, D. So this will be the resultant force, that is unknown. This is unknown. So just I put it in the red to show that this is unknown. The unknown value is 0.18 MA. So we can measure this and put it is 0.18 MA is equal to, you can measure it is coming to be 3.6. It's coming to be 3.6. So 3.6 will be kg meter square. Kg meter. So we can find out MA, which will be 20 kg. So MA is 20 kg. We have found out the mass now. We have found out the mass of the system. So mass and as well as the direction. So now what we can do is we can transfer this force to this system. So I am locking this parallel line and then moving it to this place to draw the vector. It's coming here. So I'm just drawing. So this is where this is going to be the E is going to be. This is where E is going to be. E is going to be. This is what we found out. And the mass is, we found it as 20 kg. Distance is already given, it is 180. So we got the values for this one. This is the values we got. So we located this mass and then the angle also we found out. So it is 236. AOB will be, this will be the angle to this will be 236. If you add 90, 20 and this one, it is coming to be 236 degree. So AOB is equal to 236 degree. Okay. So now we have to draw the coupled polygon. This is a forced polygon. We complete drawing the forced polygon. Now we can draw the coupled polygon. So for drawing the coupled polygon, we know the known things. 0 is the known thing is 1.8. 1.8 is the best known thing. So we start with this for C. So for C is 1.8. So this line should come straight to this like this. So what is the measurement? 1.8. We take it as 18 mm. So 18 is coming around. This is 18 mm. So now we can draw this. Then for E, so we are taking parallel line for the D vector, and we are trying to draw. So this is a parallel line. So we are tracing this parallel line for this D, and then trying to draw this. It's coming around like this. So we put a line and let us see, because we don't know the magnitude length of it, so we have to draw the vector of the other one also, E also. So for drawing the vector, we can take the vector from here itself. So let me take the vector from here itself so that it will be easy for me. So this vector and this vector are same. So if I draw is meeting at a point, take this point and let me connect it. and this is 1.8, and this is 6x. This is minus 0.18 MA into y. So now we can compute it. So we have to see the length of it, length of this, and this minus 0.18 MA into y is coming to be 3.6. So we know the MA value, which is the value of MA is already we have found out it is 20 kg. So we substitute in this 0.18 into 20 into y is equal to 3.6. So y is coming to be minus 1. So this is in meters. So it is 100 millimeter. So minus 100 millimeter. So that is, so we can say this distance, the y value is minus 100 meter. You can say r 1 meter or 100 millimeter. So that is the y value. So we got the y value, and 6x. If you know the value of 6x, you can find out. So 6x, if you measure, it is coming to be 2.3. It's coming to be 2.3. So x is equal to 0.383 meters, or it is 383 millimeters. So we got the x and y. So we got the values of x and y and MA. So here this is the couple polygon we have drawn.